everyone, so my name is Iskil Mousse. I'm system engineer at Spirent, and yeah, in the next 20-30 minutes, I'm going to provide a high-level view on how to deploy a VTS solution in OSM. So the agenda that will be, I'm trying to move to the next slide. Yeah, okay. So the agenda that we are going to follow for this presentation is the following. So first, we will have a briefly introduce Spirent Communications for those who might not yet know Spirent Communications. Then I will talk about Landslide, which is a 5G test solution that actually Ulak was referring to. Gustin from Ulak was referring to it earlier during the first presentation. And then a couple of slides on actually how during the plug test we redeployed Landslide in the OSM environment in order to test the 5G core from Ulak. So as a company, so Spirent Communications, is known to be a leader in the testing industry. We are around 1,500 people with about the same number of customers and located in a given number of countries, around 50 countries around the world. The company by itself, yes, has, I would say, pretty constant sales revenue of about $500 million every year, and reinvesting almost 20% of it in research and development every year. So the main focus on the company, is of course testing, and the goal is to provide efficient tests and methodologies to our customers in order for them to improve the quality of the solution that they are delivering. Here are some of the, I would say, main segments that the company is actually focusing on nowadays. So you have service assurance and analytics. So basically providing the capability to perform active testing in production network. So those could be transport network or mobile core network, for example. The company also provides solutions for cloud infrastructure validation. There is, the name of the solution is CloudSure, and it has also been used during the last plug test. So basically a solution that will allow you to validate your VIM, your DNFM, and also your NSD. And then another, I would say, market on which the company is focusing is anything regarding high-speed Ethernet with a solution called Test Center, which is usually the most known solution from Spirent. And then you also have, as you can see here, other areas, I would say, of high interest of the company. So I'm not going to cover all of them, of course, but you have cybersecurity, some solutions to allow you to test the GNSS or location chipset that you have in devices, and also some solutions that will allow you to perform some automotive testing, both intra-vehicular communication and also extra-vehicular communications. So, to address all those different market segments, so the company is divided in 3 business units, as you can see here, so network and security, lifecycle service assurance, and connected devices. And in each of them, we actually provide products and services. So the mobile core part, the solutions that are aiming at testing mobile core network both in lab and live environments are actually part of this business unit there, the lifecycle service assurance one. So as we all know, so 5G is a pretty hot topic nowadays. So it's the kind of, I would say, technology or a challenge that is basically having an impact on all the segments of the network segment. Basically, all the segments of the network, let's say, basically from the devices that you have in your hand, that the customer has in their hands, to some network function located somewhere in the core network. So on this part, let's say, from the user equipment to the network functions at some point, and eventually back to the user equipment. So Spirent is providing different type of solutions to address the different testing challenges that can be faced. So both testing devices, testing 5G or 4G base stations by providing some channel emulation solution. Now, especially, it's already started in 4G, but especially in 5G, so you have all those challenges regarding front pole that have been introduced. So have new protocols there that are specified, like ECP and NGFI, so you might want to test the new switches and routers that are being added in those parts of the network, so the company provides solutions for that. And our area of focus, of course, is going to be, at least for this presentation, is going to be anything regarding the core network part, and also to some small aspects we make. But in this case, mainly the core network part. And the solution that we are going to talk about, of course, is called Landslide, as you can see here, and as you can also see here. So the solution Landslide itself is mostly focusing on testing in lab. Okay, so what is Landslide? So Landslide is a mobile core network testing and emulation solution for lab and production environments. It's basically revolves around two main concepts. So the first one is the ability to test function or set of functions, and the second one is the ability to emulate functions or set of functions. For example, using Landslide in a 5G scope, you will have the ability, which is typically what we did with ULAC. We have the ability, for example, to test a whole 5G core end-to-end by emulating both the user and the genome base all together, and also eventually some application server on the NC interface on the IP network part. Or you also have a possibility to emulate specific functions. For example, you could emulate an HSS. In the case of 4G, you could emulate, I don't know, for example, a UDM in the case of 5G, an AMF, an SMS, or VTS. So of course, this here is emulation for the purpose of testing, so it's not production-grade emulation. The goal is not to sell those emulation capabilities to customers for them to deploy in a production environment. So this is all aimed at testing. So in terms of testing, so two main types of tests will be available. So end-to-end testing, as shown here, and also node isolation testing. So here you have some of the functionalities that are available. So you could do 5G core testing and emulation. You could, for example, test, as you know, so the 5G technology is actually being introduced in phases. So the first phase is the NSA, so no standalone, and then service provider will move to the standalone implementation. If you want to do some non-standalone tests, the solution is able to do it. And yeah, in case you might be, for example, interested in doing some interact testing between 4 and 5G, it's also something that can be provided by Landslide. So here we just have a list of some of the main, I would say, use cases that Landslide users are using. Okay, so in terms of network functions, so here in this slide, we basically have a description, a description of 4 5G mobile network, from the access part, also from the devices to the network function, deep far at some point in the core network. So basically, all the entities that you see here in dark blue or in dark green are the elements that Landslide is able to test and emulate. As I was saying earlier, so the solution provides two main functionality, testing and emulation. So basically, what does it mean? It means that with Landslide, you could eventually emulate a whole 5G core, because all those elements here are in dark blue, or you could also eventually test a whole 5G core. How will you test a whole 5G core? It will be, of course, by emulating GNODEs and the user data associated to that, or to those GNODEs. So the boxes that you see here in lighter blue are the ones that Landslide can only emulate. So dark blue or dark green, we can test and emulate them. Light blue, we can mainly emulate those. So all those functions that are provided are available in what we call test cases in Landslide, and those test cases can be configured in defined type of Landslide agents, let's say. So those agents could be physical network function, virtual network function, or container-based network functions. Those network functions are typically called test servers in lab environment or active test agents in production environment for Vision 1. So what does the solution itself really look like? So basically, the solution is made of two main parts. So let's say two main entities. So the first one is the task for test administration server. So it's basically, let's say, the node that is in charge of hosting the test case configuration. also hosting the result of the test cases that have been executed. So you connect to the task, to the test administration server, you define your test cases, you run them, and you can access from that task to all the KPIs that will be collected. Of course, that task can also be driven via a tickle or REST API, depending on the type of API that you actually prefer. In some use cases, actually we're talking about testing core network. You might want, for example, to use some authentication credential coming from real SIM cards. So it's also something that is possible. You could associate to your test administration server what we call SIM servers, from which the AKA parameters are actually going to be fetched from. When the user that you're emulating will try to interact with the core network, no matter if it's a 4 or 5G core network. So once you're here, you have defined what you want to do. Basically, the logic of the test case that you have defined are going to be pushed onto the other type of entity that we call test servers. So those test servers are the entities that are in charge of effectively executing the test cases and computing and doing all the measurements. So those test servers could be either hardware-based or virtual-based. So as I was saying earlier, so PNF, GNF, and CNF, and you have different flavors depending on the level of capacity that you are willing to achieve. So for example, in case of virtual, you have all the different levels of capacity from 20 users to 1.25 million users that can be emulated per test server. And of course, it's those test servers who will have test ports that will be connected to your system LFS. So that could be any node, that could be, for example, your whole 4G core or your whole 5G core. It could be a specific node, for example, an HSS, a UDM, a TCF, or whatever specific node that you want to isolate for the purpose of testing. So today, so in terms of, I would say, virtual, so here are all the different environments that are supported. So KVM, OpenStack, I mean, all the main ones, VMware, AWS, Azure, and lately, so actually it's this year, so the support for Docker Kubernetes has been added. And okay, so how are you going to use Landslide in an OSM environment? So this diagram tries to, as I was saying earlier, so providing a high-level view of how this works. So basically, you start with a single image. So if you are deploying on an OpenStack environment, you will use your Pico2 image. If you are running it, if you are willing to deploy it on an ES6-based environment, you will use your OVA image. So you have a single image, and it's that image that once, it's only that image that you need to actually perform the deployment of a different type of entities that you need. So typically, you will first need a virtual task. So because that will be the one that will be in charge of hosting your test cases and collecting and hosting also the test results for post analysis. And this is typically a static entity. And yeah, so if you want, you could deploy it via OSM and use a network service, or sometimes you could just have a hardware-based appearance there, or a virtual machine that you have deployed manually for this purpose. So the entities that are really dynamic, that could be also, of course, static. That it all depends on how you want to perform your testing. How you want to perform your testing activities are the virtual test servers. So those ones typically could be either static, so you will deploy them at different locations in environments and use them whenever you need, or they could be dynamic, meaning that for each test case that you want to use, you spin them, run the test case, and then delete them. They actually don't host any specific information. All the hard drive, all the information that needs to be stored are actually stored in the virtual task. Okay, so once you actually deploy those VMs using the same image, you just need to run a couple of commands. So actually, it's only one or two commands that you need to run to have those VMs being configured. Or so a pretty simple way for you to actually write this step. Where actually via OSM, you will have deployed, for example, one network service for your VTS, one or multiple network services for your virtual TSCs. So you could have one network service that will contain multiple virtual TSCs, or maybe one network service with only one virtual TSC. So the nice thing about this is that basically you are able to split the resource management part from the, I would say, technology for 5G part. So you deploy your resources, and the resources that are being deployed, so here the VTSs and the VTS1 and VTS2 in this case, they are totally agnostic to the type of test cases that you are going to run later. This will be just a matter of assigning to them the right test cases for the right network function that you actually want them to emulate. So you define your test topologies here in the task, the network function. Then when you are ready to run your test, you push those logic onto the different virtual TSCs that you have pre-deployed or that you have deployed in your environment. You run a scenario and then you collect the statistics. All those things by only interacting with the manager, who will be in charge of interfacing with the other entities there. This slide shows a network service descriptor of a very simple back-to-back example. So in this case, it's a network service of a virtual TSC, assuming that the virtual task has already been deployed somewhere, and you basically have many two types of networks. So you have a management network, which is used for you to connect to your VTSs if you want to, but mainly for the VTSs to interact with the virtual task, to push the test case logic and to report the metrics back to the virtual task. And then here you have the virtual, you have the test ports that are used to effectively generate the emulated traffic that could be sent either to another VTS, like here in the case of a back-to-back emulation, or eventually to a 5G core or 4G core, or whatever network function that you actually want to test. There is actually one key requirement when you are willing to use Landslide, the virtual TSC, is that the support of DPDK is required. So it could be something that you might want to advertise in the EPA of your VNFD, or eventually something that will also be easier to do is just to have the host on which you are deploying your VNF to natively expose the DPDK capabilities to the VM that are deployed, that are instantiated on it. On top of that, so there is another, this is not a very hard requirement, it's a pretty, I would say, a soft one. So it's recommended for you, to have a VM that is able to support the deactivation of port security, so that you'll be able to spoof the IP addresses that you are using for the test port. So typically here, as the Landslide is really a testing solution, so you have a capability to do some legacy. So all those, I would say, main requirements will end up in a set of NSD and VNFD, and this here is just a screenshot of the VNFD that will translate into this diagram. Of course, so the dotted lines are not represented there. So here just one management port and two test ports for back-to-back scenario. You could easily imagine here the possibility in VTS1, for example, to emulate an NRF, and for VTS1 here to emulate an AMF or an SMF or whatever other network function that needs to register to that NRF. What else is interesting there? Yeah, I think that's mainly it here. Okay, so in terms of what has been done during the previous plug fest. So as Gulsum was saying, so we did two types of testing. We did a 5G core end-to-end signaling test, and we also did an NRF testing scenario. So here I'm only going to talk about the 5G core end-to-end signaling scenario. So what you see here is the user interface of Landslide. So basically, as I was saying earlier, you have different test cases depending on the network function that you want to emulate. So once you have deployed your virtual TSs and your virtual tasks, you connect to your virtual task via a graphical user interface, and this is what the graphical interface actually looks like. For each test case that you want to do, you have a specific graphical user interface with a diagram that basically shows you the topology that is going to be emulated and highlight here in purple the elements that will be effectively emulated. For example, this test case, which is called AMF nodal, when we will be running it, what it will do is that it will emulate U and G node D all together and expose the N1, N2, and N3 interfaces to the 5G core that you want to test. You could do capacity testing, you could do mobility testing, and different types of things. So here is the first scenario that we did during the flood test. So basically, we had one network service for the virtual task, and we had another network service for the virtual TS. So here you have the network service for the virtual TS. So it was NS that only had one DNS inside because we needed one. So that DNS was configured as a virtual TS. That virtual TS has one management network to communicate with the virtual task, and it has two test ports. So one of them was actually mapped to the Vim network N2 because it was providing the connectivity to the N2 interface of the EMS from ULAC, and we had another link mapped to the Vim network N3 that was actually the same thing but for the N3 interface, so connecting to the UPS. So as you can see, with a pretty, I would say, a pretty simple network service, you are able to deploy an entity, in this case, one virtual TS, that will actually provide you a big range of network functions. So here we only use the ability to emulate the 5G access network, so you use a GNOD, but you could easily imagine here that in that same VTS, we could have decided in the test configuration to also, for example, emulate on top of the access network, we could have emulated the EMF SMS in order to isolate the UPS. Or for example, we could have emulated the access network, the UPS and the SMS in order to isolate the EMF. So you will have that duality in terms of functionality, the ability to test and emulate, which allow you to do end-to-end testing and load isolation. So what we did, we deployed that one, we configure the test scenario, and we run a signaling test. So here are some screenshots of the tests that were done. So yeah, so this is regular 2GPP call flow for registration to the 5G core and establishment of a PDU session. So as we were saying earlier, so we didn't have enough time to perform some throughput characterization of the performances that were available. But honestly, as long as the PDU session is established and the gear are up, the packets will flow, and then it's a matter of finding ways to optimize the performance of the environment on which the DNS actually deployed, or the DNS actually deployed. So when you run your test, so of course you have the ability to have some pickup traces like this one, but also you have a big range of counters that are available for you for each of the interfaces that you're emulating. So in this case, as I was saying earlier, so we were emulating mainly the 5G access network, exposing the N2 and the N3. So here you could have some counters actually related to those different interfaces. So the one that you see here, so this is some counters for the N2 interface, for the SCTP layer. You go upper in the stack, and you also can have some counter for the NGAP, the MM, and the SM layer. As we didn't effectively generate some user plane traffic, we don't here have some counters for the user plane part. But those are available if you had configured it in the test case. And this is, I believe, actually the last slide. So the last aspect was the first participation of Spirent with Landslide. So as you can see, so there are a few things that we can actually do on top in order to add more functionality to Landslide with regard to OSM itself. So today, the configuration of DNF either as a virtual TS or a virtual task was done manually because it's only one single command basically to run. But of course, we could find ways later to automate all that. We didn't have time, sorry, to try the virtual TS's CNF. It's something that eventually we could give a try later on. What else was interesting there? Yeah, so as you have also seen, so the virtual TSCs can actually be deployed on a wide variety of beams. So eventually, I mean, we already have all the files that are needed to deploy them on VMware, the images that are needed to deploy virtual TSCs on VMware and AWS or other type of VM. So that's something also that we could eventually try. And yeah, I mean, there is really a wide range of tests of things that we can actually test with that OSM. On top of that, it will also be nice. I believe that's something that we'll surely discuss with ULAC to basically integrate the Landslide VTSs, for example, in a 5G core workflow deployment, so that you deploy your 5G core functions, and at the same time, you also deploy the Landslide VTSs, run a test, as we saw earlier. So the tests are run via the virtual task. Those virtual tasks can be managed via Iskil API or REST API. So typically, you could use a REST API, trigger a test, collect the statistics, and have a verdict that will validate that the instantiation via OSM of the 5G core is really successful and also functionally running. So that's something that could be nice. Yeah, and some additional things that we could eventually propose to some way to OSM, or some kind of lesson learned, I guess. So today, when we are creating a VNFD, we basically have to every time specify the requirements of the DNS, basically in terms of CPU, memory, and all those things. So I think, I mean, we think that it could be nice to have the ability to directly specify when we know the VIM that we are going to use, and we know that specific flavor is already available in that VIM. It could be nice to have the ability to specify directly the name of the flavor in the VNFD. So that was just something to propose. Typically, during the plug test, so as I was saying earlier, so the virtual TSCs require the support of DPDK. So in terms of the VIM, so we already have a flavor there that had all the right CPU flags and everything fine, so that DPDK can be, so that DPDK is available. We could have, if we had the ability to just indicate the name of that flavor in the VNF, that would have been easier rather than having to go through the EPA and all the cycle of communication between the manual and the VIM, just to have basically the same thing, because we already have it in the VIM. There is an option that was also available, so the use existing flavors. So I tried it, I'm not quite sure, but it was not really working. So I have seen that in case of APA, for sure, it seems to not be supported. And even without using EPA, it didn't really seem to work. So it kind of come back to the first point, but it would be nice to be able to just reuse what is already there. And yeah, and the last one, so that's probably something that was going more to help me, because as I said, first participation to the plug test, so I'm not that much familiar with the whole, and OSM, I'm not an OSM expert, but it would have been nice to have in the OSM tutorial an example that focuses on DPDK. As we are talking about, of course, virtualization, and as you know, for example, in the case of 5G, so you have specific functions like the VPS that are going to need DPDK. If you have some example already there that we can just copy paste, that will help us in some cases, I think. So yeah, so that's basically it from my side. Are there any questions?